Okay, everyone. Hey, it's Brett with Building SP. I thought we'd get started. Other people may join on as we go, and I'll manage that as we go through. But thank you very much for joining us. We're very excited to show you how GenMEP works with Dynamo because we really think that that is a great way to provide tools for you, the building community, to be able to integrate tools both in Dynamo and through GenMEP into the workflows that you have and that you currently use. So the way we're going to structure today, I'm going to do a quick overview and go through a couple of things, and then I'm going to get out of the way and have Jack Shea and then Ben Bushman walk through first GenMEP real quick and then the Dynamo functionality that we've exposed. So kind of going through a couple of kind of logistics that we have. Betas are available if you don't currently have a beta. So get a hold of me or anyone on the team and we can get that moving for you. We are recording today's session and we'll make it publicly available after the presentation for you, and then if you want to pass it on to teams that are at your firms. And during the session, if you have questions, feel free to shoot me a chat through GoToMeeting or shoot me an email by mail, and we'll be sure to address it, or we'll follow up afterwards and go from there. So with that, I can talk about who will be presenting a little bit. So my name is Brett Young. I'm the CEO of Building SP. Before that, I ran a BIM consulting company, and before that, I worked for 9 years for a general contractor. Jack Shea will be presenting second. He is a licensed structural engineer in the state of California. He has experience at a general contractor, level 10 construction, as well as Cahill Contractors, and before that, he worked for Dave & Culp. Ben Bushman is an electrical engineer by training, and before working for Building SP, he worked for Integral Group. So kind of overall, we are the construction product team for Building SP and for GenMEP. To kind of give you a feeling for why we're kind of doing our work, building information modeling is a very important part of what we do. I think everyone on the call is very familiar with BIM, and we only see that the use of BIM will be expanding across more and more markets, and there'll be more and more going on. But one of the major things that we do within BIM is this process of clash detection. And we really think that clash detection is a very broken workflow. If you think about it, it is analogous to having someone check your spelling or doing software debugging, where you're going through and looking at defects that are in something that has already been created. And really what we're trying to do is make better tools that bake in that inherent quality rather than going through these difficult revisions and going through these meetings to correct things that are broken. Kind of basically, computers are very good at doing this type of work. So what we're doing here is, again, creating better tools that allow you to manage, design, and model through the BIM workflows. And more specifically with Dynamo, what we've done is all of our functionality that we have within GenMEP that we've either shown you in the past, or if you've looked at our videos, our YouTube videos, or our demos, all of the functionality that we have there is being exposed to Dynamo. So within Dynamo, you can go in and create visual scripting and use auto routing between points, use automated hanger tools, and do other things like that that are not part of the core Dynamo package, but which are tools that we're adding to that package so you can go do things. So rather than wait for us to go and develop workflows that capture what you do, you can go and integrate the tools that we've created into what you do so that they work for the workflows that you go and do. So with that, so kind of how we're going to structure and how we're kind of describing our work. Whether you do routing manually for MEP or using GenMEP or using Dynamo, you kind of have 4 steps in what you kind of do. The first step is you have to figure out where you're actually going to go and route. And we kind of call that creating the plenum spaces. You have to figure out where the routes can go and live when you go and do them. The second part is you have to define your start and end points. And if you're doing it manually, that's just connecting up, modeling down the line. But if you're in GenMEP, it's a little bit more formal of a process. And then you have route characteristics. These are kind of like what a conduit can and can't do, or what you kind of prefer that you would and wouldn't do. If you're doing it manually, you kind of inherently know what your system can do. But again, when you're in GenMEP, we have options that let you pick the parameters that define a route. And then you have overall route decisions that kind of are described as either waypoints or defining the spaces that a given pipe, conduit, or duct can and go and be routed within. So what we're going to show you today is we're going to show you how you do these 4 things within GenMEP, and then we're going to show you how to do the 4 things within Dynamo. And with that, I will turn it over to Jack, who can go through the workflow for GenMEP.
Hi everyone, thanks for joining us. This is Jack Shea. I'm the product manager for Building SP. So for those of you that have not seen our demos and videos yet, I will be demonstrating the current features of GenMEP, and after that we will move on to the Dynamo portion of this webinar, which Ben will present. So after installing our software, you open up Revit and you go to the add-ins ribbon, where you will find the GenMEP panel. The AutoRoute drop-down menu has all of the features that I will be going through today. So I'll start here in my sample model and move on to an actual building model. The sample model has a bunch of short sections of MEP families that define the start and end points of my routes. Before we route, the first command that has to be executed before any of the auto-routing features can be used is regenerate plenums. This function goes through the Revit model as well as any linked models, which could include other Revit models, IFC format files, exported from CAD, and point clouds if you're working with LiDAR scans, and stores all that information so that when the routes are generated, any obstructions from the existing models can be avoided. This is what enables the completed routes to be clash-free. So after I select Regenerate Plenums, a pop-up window will show the progress of the scanning and storing process. In this case, it'll be very fast because the model I'm working with here is very small. So I got a message there that this has to be executed in a 3D view, which I'll do now. Now I'm ready to route. I go to AutoRoute and I select the GUI AutoRoute function, which requires me to select the endpoints of my start and target stubs. So these stubs are just short sections of standard Revit MEP families. We sometimes refer to them as waypoints, as Brett mentioned, because they allow us to guide the location of the route. Once I select the second endpoint, a pop-up window shows up that allows the parameters and algorithms of this route to be specified. I'll go through all of these parameters real quick. Starting at the top, the routing selection is currently defaulted to a direct route. We have a couple of other options that you can see here that are currently disabled for the public version as we finish some internal testing. I'll explain them as well. Channel will allow the users to define an elevation range for routing. This would be useful during MEP coordination when we sometimes assign trades to use specific zones to help with reducing clashes. So for example, you might want sprinkler piping to go above all the other trades. You would break down your overhead plenum into several channels and assign the highest one to fire protection. There will be a separate channel editor that allows these zones to be defined. Next, follow walls and ceilings is intended for use in electrical and mechanical type rooms where the entire room can be used for routing, but you would want your conduits and piping to go along the walls and ceilings so that they don't run through the middle of the room. Moving on to routing algorithms, we currently offer two algorithms. The first one, called the late alignment algorithm, is the default. The second one, orthogonal, forces the route to only take 90-degree bends in plan, but still allows for other angles specified below to be used for the vertical offsets. In other options, we have a route name that can be specified if desired, and all of the elements of the created route would be tagged for the, with this name. So I'll type in conduit 1 here. Next, the clearance allows additional spacing between the route and other elements. I'll describe a couple of examples where this might be useful. If the mechanical model is missing duct insulation and you want to make sure you're providing sufficient clearance when going around ducts, you can specify this dimension as a thickness of the insulation plus any additional clearance. Another one is that architectural and structural models don't typically show fireproofing. Plus, and so if you were routing around beams, you could specify the thickness of the fireproofing plus any additional clearance. Next is the timeout, which is the amount of time that's allowed for GenMEP to find a solution. The solve to failure checkbox shows a portion of the route completed if the route was not solved during the specified timeout above. And lastly, the angle allows the fitting angle to be specified. These angle selections that are shown here are intended for conduits. If a pipe is being routed, we currently only allow 90-degree angles to be used. Changing the parameters for the same pair of stubs enables generative design of MEP systems by creating different route solutions between the stubs. So you can run a route and then come back and change the options or select a different angle or algorithm and run it again and get a different solution. So when I click OK, I will get a class-free route for this first pair of conduit stubs. So as I mentioned, we can use the function again and change the parameters. This time, let's say I'll use a 45-degree angle, and I get a route that uses 45-degree fittings. So let's say you prefer to work in a 3D view. In this case, it may be difficult to use GUI AutoRoute to select the endpoints because typically one of the endpoints will be blocked unless you rotate the view. So another way to select the stubs for routing is to use the GUI AutoRoute closest function. This allows me to just select the entire element, which is particularly useful if you're working in a smaller scale view where you're zoomed out. So this time I'll change the name to conduit 2 and choose 30 degrees. So as you can see now, we go around this duct obstruction using 30-degree fittings. Next, I'll show the multi-select feature. If you have a rack of pipes or conduits which would require all the same routing parameters, it will save you time from not having to select individual pairs of stubs. Even though these are typically different trades, I'll demonstrate the feature on the 2 cable trays as well as the 2 ducts that are below. So one way to select the stubs is to click on them one by one and click Finish, or I can select everything using a selection window. But this time I have 4 different routes, and obviously I don't want them to all have the same name, so I'm going to leave the route name parameter blank. and name them later. I'll use 45 degrees for these routes. And we'll move on to the last route here, which is a pipe. So when a pipe is selected, since we only currently route pressure piping, all the other angles are turned off by default and only 90s are enabled. And I'll type in the name here since it's just one route. Okay, so now I've completed 7 routes. For those of you that may have seen our past videos, we make frequent use of a batch auto route function that allows multiple routes to be generated at once without having to specify the properties. We do this by storing all the parameters for these completed routes in a batch file. I'll now open the batch editor and show you how to do that. Load from memory brings up all of the route parameters for each of the routes I just completed. Now I can type in the remaining route names. And the route editor also allows you to change the parameters that we previously specified in the current properties window by changing the algorithms, the angle, clearance, the timeout, as well as the software failure box. So once I've named these routes and changed any other parameters that I want to change, I can save this file now into a batch file. I'll call it routes all trades. It's saved as an XML file. Now that I've saved it, I can delete the routes from the memory. If I wanted to load an old batch file, I just select load and select the file. So I'm now going to undo these 7 routes and show you how the batch file works. But before I run the batch file, I'm going to move some of these stubs around. So that's a piece of equipment that these conduits were connected to moved. So we're going to have to move these stubs. And let's say the mechanical detailer also changed their duct model and moved the ducts over. So we'll move over a couple of feet and we'll go ahead and move it up as well. So we can still select each of these start and target stubs and generate new routes using the various GUI auto route features. But since I have the batch file, I can just run the batch file, which makes selecting the routes individually unnecessary. I'm going to run the batch file with batch auto route, and I'll run the routes all trades file. Now we have 7 new routes. Because we're storing the element IDs or the GUIDs of these stubs, I was able to move the conduits around as well as change the location of the obstruction and still run the batch file. Model changes can be made by other disciplines and the batch file can be executed repeatedly to generate routes without having to click on the stubs again. Note that in this case with the new routes, since the duct moved up, the offset to the bottom of the duct got smaller, so the algorithm chose to go under it. If we zoom into the 2 conduits here, it looks like there's quite a few extra bends. And it turns out that the second conduit route is trying to go around the first conduit, and so it ends up creating an extra offset with 4 bends. So let's see if we can redo these 2 routes to find a better solution. I can use the delete route feature to delete it. So this time I'm going to use a shortcut for delete route. You can create shortcuts for all these functions, which speeds up the process of having to go up to the drop-down menu. So I'm going to rerun this first route. This was conduit 1, and I will use 90s only since that's already checked here. And then we'll do the second route, say with 22.5 degree fitting. So it's much cleaner and than the previous two routes, and so I like this solution and we'll keep it. So I want to move over to the other part of this model, which is just a very simple electrical room, and show you another feature. So we already have a batch file that's set up here, and I'll run the batch file. And the one thing I wanted to show here is the intermediate conduit stub here, which breaks up this particular route here into two routes. The intermediate stub allows us to have some extra influence over the route. So let's say I don't like where this particular route is going through the middle of the room. So I'm going to grab this intermediate and just move it near the wall. Let's say 8 inches. And now I can rerun the batch file. And since I've moved the intermediate stub, now the route between these two panels is forced to go through it, and so it's now along the wall. So the intermediate stubs are useful where you want to have some extra influence over the routes. It's essentially an extra waypoint that allows you to guide the route. I'm now going to switch over to a different model to demonstrate routing through a building. In this model, we'll route some electrical and piping. Note that in this model, if I go down to the links portion of the project browser, that the architectural, mechanical, and structural models are all linked in. So, as I mentioned before, the first thing you have to do is to regenerate plenums. But let's say that we just want to go ahead and start running the batch route. Again, using my shortcut, I'll run a batch file here. So since I forgot to regenerate plenums, it's done automatically in this 3D view. In this case, since we have to scan the primary detailing model that's on my screen, as well as 3 models that are linked in, it takes a little longer. I think it takes about 30 or 40 seconds. So when you're running batch files, the route progress window shows you the progress of each route. The first set of routes is a cable tray that goes across the building. This is followed by a set of conduits that might form part of an electrical distribution system. And we'll finish with some return and supply piping to all of the HVAC equipment. So I want to point out that we realize that these are typically 3 different trades and that you wouldn't typically have the same person detailing electrical and piping, and you might even, within electrical, you might even have 2 different detailing specialists for cable trays and conduits. At the same time, we want to show you just the power of the GenMEP and the use of the batch file and how quick we could generate routes. So in this case, we generated about 40 routes of conduits, piping, and cable tray in less than 2 minutes. And Anytime the other linked models change due to other disciplines updating their models through coordination or other changes, you can run the batch file again and get a new set of solutions that are completely clash-free. So the last thing I'm going to go over is the routing plenum, which is the, as Brett mentioned, is the space that we define in order to tell our software where to route. In this case, we do actually use a Revit space. So I'll open up a section in a plan view here. So I'll select the space that we defined, which is this entire, almost the entire area over the first floor ceiling. And as you can see, it's highlighted in the section and the plan view. So we'll go to the space properties, and when GenMEP is installed, anytime you create or open a space in your project, you'll see an additional parameter at the very bottom called use for auto routing, and you just have to check that box, and that tells our software to scan that area and store it for the routing. This saves time by not having to scan the entire model and areas of the building where you're not using the tool for routing. And if you're not familiar with creating spaces, there's information on the Autodesk Knowledge Network, and we'll also be producing our own videos as to how this could be easily created for routing. So with that in mind, I'm going to hand over to Ben to talk about our work in Dynamo.
Unmuted.
Thanks, Jack. Let's share my screen here. All right. So everything we've shown you so far is working really well inside of Revit, natively inside of Revit using the Revit API. But we decided to make our routing engine have public access to that and create an API so that we can share generation of stubs in Dynamo. And so in Revit, as Jack just showed you, we ask users to manually draw or somehow create start and target sections of system. We call them stubs or waypoints. So we decided that bringing our routing engine to Dynamo would be very helpful, because instead of using a manual method to generate the start and target points, you can use a programmatic method and the logic in Dynamo to extract start and target locations for your a company kind of preference. So the basic way you use GenMEP in Dynamo is you open up a project and you click Import Library. You work your way over to Program Files, GenMEP folder here, and then the Building SP API DLL is the library you want to import. So I've obviously already done that, so it's not going to let me load it again. But what that does is show a library over here on the left, just along with all the other fun libraries that you can use in Dynamo. So we have some different choices, but the main deal here is we want to create nodes that have inputs for users to create start and target points. So this is the main engine node for the auto routing, and we also have routing parameters like this that can be input. So the way that actually works in practice is this yellow group here is a sample Dynamo file that we have that we send out with our newest installers. So you'll receive the model that Jack spent a lot of time working in batch files and showing how GenMEP worked in Revit. We'll send you that example model, Revit model. We also send you the Revit model I'm using and this example Dynamo file as well, so you have something to work from. But this yellow block, this yellow group is what we have built, and then going from there, everything to the left of this yellow block is the way that I'm, in this example, generating start and target points. But I'm going to talk through a little bit about the individual inputs we have here. So the three main pieces to the routing engine are start element, target element, and the routing parameters. I'm going to talk about routing parameters real quick. So these parameters should look familiar. Jack just walked through each one of them in the GenMEP natively in Revit, had a nice routing preferences window that popped up, and he changed the name of some routes and changed some angles and changed some of the routing timeout and such. So these are the same preferences that we looked at before, and those get fed into the routing parameters node, and that gets fed into our routing engine. The start element and target element are really what this is all about. Start element and target element are looking for the element ID of a start or target system stub, basically. The same deal we have in Revit that Jack showed you. A 2-foot long conduit has an element ID, so we feed that into start element or a target element, and that's how you generate your start and target points. So in this example, I have kind of a little complicated, probably not super efficient way of defining start and target points, but at a basic level, this example is showing 49 routes at 9 feet, and they're spaced 2 feet apart in the X plane, and then spaced 60 feet apart in the Y plane at a fixed distance. So I create points here in those two groups, feed them into a list, and then feed those lists into this draw conduit between those 2 points group. So out of that drawing conduit, so at this step we're looking at, all we have is 49 start stubs and 49 target stubs that were just drawn here, and they get fed into a list of 49 inputs and 49 targets, start and target elements, element IDs. So let's take a look at how it works. So I click run, I'm in a 3D view. My start and target stubs were placed very quickly, drawn in by Dynamo. You might have seen the regenerate plenums quickly popped up. That means we're in good shape because now we're routing. This takes, I don't know, 37 seconds or so, and it's generating 49 routes in between the stubs that were drawn in earlier in the file. And so, oh wow, I couldn't even get to that happened too quick. So let's take a look at this real quick. So a nice grid of 49 routes that work their way across this example. Some of them go under the steel, some of them work through the penetration, and along they go, and all clash-free, generated through Dynamo with no interaction from Revit at all. And so I wanted to, let's see, I wanted to just change a parameter over here. So we're going to change this to 8 feet 9 inches and change, I'm going to generate a second set of routes. So 48 routes that are also 2 feet spaced at 8 foot 9. So I scooched them over a foot so they're diagonally over. And let's see, I want to change. Instead of 45-degree bends, we're going to make all the routes use a 30-degree bend. And so run it again, draw in new set of stubs, and now we're finding 48 new routes that are in the same model. And so we think giving the power of Dynamo to generate start and target elements for individual users to figure out good ways to do that on projects, right? So I imagine a couple main ways this can help off the top of my head. Revit has, if you have a Revit model that has electrical circuiting completed, you can use Dynamo to connect all of the Revit circuits. As you can imagine, a circuit has a start point and a target point element, start element and a target element, so you could auto route between all circuited elements in a model just by using Dynamo in one swoop. So that's a pretty good use case. We also are pretty excited about being able to look at different elevations for either a start point or a target point or even an intermediate stub, and using Dynamo to iterate over an elevation, for example. So if I wanted to influence how a route was working, I might want to change the intermediate stub elevation at quarter-inch increments and let Dynamo crunch on that using our routing engine and produce different solutions to see which one we like the best. So we're really excited about the Dynamo power, the power of Dynamo with our routing engine. We've been running fast with this for a little over 2 weeks, and we've got pretty far. We have some pretty interesting new APIs that we're working on that give different access to other tools that we've built, again, through Dynamo. And we will be sharing those in a future blog post or webinar. So stay tuned, but we think as this works right now, there's a lot of promise on how you can generate start and targets and route between them and do some fancy things. So with that, I'm going to hand it back to Brett to finish it off.
Great, everyone. We have time for questions, and I've been kind of addressing questions as they've kind of come along, and maybe so if you have questions, chat them to me while I talk about some of the questions that we've already had and can address them. One question was, when you refer to plenums, does it mean ceiling space as well? And so when we talk about plenums, we've standardized on routing within spaces that you define and then that we tag. So if you have a building and you have an electrical room versus having, the conference room, you can have the entire electrical room be a space for routing, as opposed to the conference room where you only have the space above the ceiling kind of routed. So really, when we're talking about plenums, we're talking about routable space, and you define that routable space by creating literally a space. The next question was, and I think this was particular to electrical, are the components industry standard, or is this a field bend install? And the answer is that we use standard Revit families for everything that we do, and so the fittings are actual Revit 45s and Revit 30s and Revit conduit. So they're not field bent installations. They're actually a definable part. And we are working with a couple of other people to kind of refine that and think harder about whether or not we can do more to how we expand that and how we kind of customize so that you're doing a particular part in what you do. The next question was, how about sloping requirements of piping? And our conduit logic that we built can go in any angle. So the conduit could be used for cable, for example, and that logic also works for sloping drains. And so the algorithms are ready to go tackle the sloping drain problem, but we haven't gone through and tackled that yet because we have to do more thinking about how drainage piping is run and some of the parameters that go into drainage piping. In particular, drainage piping has, for example, venting, and it also has lots of variability in how you can do wides, combos, and other types of parts for it. And so we have to do some thinking about how we're going to tackle that programmatically so that when we go and do a route, the plumbing route is conforms to what you want to go and route. So so the short answer is that we're not ready for drainage sloped piping, but it's on the roadmap, and we expect to tackle it soon. Another question was, what happens if the batch file is run without deleting the original routes? Well, if you run a batch file and you already have the routes in there, obviously they have an obstacle in the way, so it just won't route. We have seen, and this was kind of an error, we have seen a funny thing where it routed around the other side of the conduit if there was nothing on that end or the pipe, but that was kind of a funny thing. But yeah, if you run the batch file again and it already has a route there, it won't route because there's something in the way. Last question I have that came in while we're going through the presentation. Are there different sizes defined in one route? And we currently do linear, what we call linear systems. So we're not handling branching, reductions, or other types of higher level system type logic yet. So we don't, again, the algorithms would work the same way, as you got to a reduction, it would continue to route on either side with a different size, but we have yet to program in that type of functionality. The likely first pass at that would probably be with ductwork and going through and creating configurators for ductwork so that it would correctly auto-route and configure and resize as it kind of went down the ductwork line, as it branched and as it peeled off. But that hasn't been done yet. We do feel that if companies wanted that functionality on their own, they could use Dynamo and programmatically do that on their own before we get there. So that definitely is a possibility for people to go and tackle. Okay, so there are a couple of questions that have come in, and I'll start to address those. Could you use a combination of fittings, 90s and 45s, within one route? And we currently allow for combinations of fittings when you have fittings that are changes in elevation and changes that are in plan. So if you only wanted to use 90s in plan to create an orthogonal route, but wanted to allow 22.5s or 30s, we have that functionality. We don't yet have the functionality to do, prefer 90s but do 45s if I can't find a 90, or that type of discretion. That again is on the very near term roadmap, but we don't have the ability to do combination of fittings when they're in the same plane of the route. Let me think here. Okay, so Marcus Armenta asked, can this logic be used for cable runs as long as I have start and end points? It can be used for cable runs. Cable runs are nearly identical to conduit, except they have they can go at any angle and they have a defined bend radius. So as long as we can define a bend radius and do a cable run, those are also within what we can do. So Hare with Whiting Turner asks, what are the families that are within or outside Revit that cannot be recognized by this feature? That's a pretty broad question. Right now, we're currently, what we do is when we programmatically are looking at a start or a stub, we go through and we determine what type of system it is based on the information in Revit, and then we go and route. So we have to be able to discriminate between what is a conduit, what is a pipe, and what is a duct. So if you have custom families, we can talk about how we can come up with custom behaviors, but that is currently how it works. I suggest that you go and try it, and if it doesn't work for a particular family and you have a particular behavior, we can get you to describe it, and then we can roll it into the functionality. Next question comes from Johannes. Is it possible to add additional conditions to the routing? So for example, after a component, there must be 3 times the diameter of the duct before a bend, or something like that. The way that we would do that right now currently is that we would have it, we would put in an intermediate point that was offset from the component that you were doing. So you'd have it hit a waypoint and have it hit that point before it did the rest of the route. Within Dynamo, though, you could come up with a script routine that would do that logic for you. So if you had a particular, let's say you had, you know, some large number of boilers or some typical type of system, you can come up with your own script logic to make it do that logic on your own using Dynamo. And if you have an example, it might be good to email us and talk about that example, and then we can help you work out the script that would allow you to do that type of functionality. I think that is the extent of the questions that we currently, oh, here comes another question. Do you have to use conduit as the start and end points, or can you use a fitting or connector on a piece of equipment as the start and end? And I'll have Ben answer that question.
Yeah, so at the moment, we do need the actual conduit or pipe or duct as drawn in as a piece of that system. We are working on adding a connector, as in like routing from a JBox to a panel directly. We are working on that kind of feature, but at the moment we would need you to draw a little piece of conduit sticking out of the JBox and a little piece of conduit sticking out of the panel at the moment.
Any other questions before we log off? We're available for questions after, and you can call us at any time. Okay, so I thought I would talk about a couple of things that we have. Okay, Rainier out of Denmark said, perhaps you could mention that you could use Dynamo to generate stubs. Yeah, Ben, you want to walk through your stub creation tool again real quick?
Yeah, let's take a look. Yeah, where is that? Where are we here? This one?
And while Ben's doing that, I can talk about a couple of functions that we have that we've added to the API that we're currently testing. The first thing that we have is we have an automated hanger tool. And what it does is if you define a point in a Revit model and pass a parameter that defines a cylinder diameter, we will check whether or not there's anything within that cylinder vertically going up. So the way you would use this is if you had a pipe, you could ask whether or not it was acceptable to put a hanger at that location in the pipe, and then it would do the check, and if it came back as being clear, you could have Dynamo auto model in the hanger for it. So we currently are testing that for the vertical hanging component, and then the step after that is to, once we have that kind of tested and delivered to you, we'll do that for 45s as well. So the same functionality would be is if you have a location and a direction and pass it to Dynamo, you can define whether or not your seismic would be able to fit within that cylinder, or figure out whether or not there's a clear path for that seismic brace to be put in. One other piece of functionality that we have, which we think is important for the generative design portion of all this, is that we have a interrogation tool for MEP systems. So if you have it define for example, a duct run, it'll return back to you values for that duct run that you can then determine whether or not it is, you can look at, for example, the head loss or the amount of linear feet or the number of bends for it. And by doing that generatively, then you can run it a couple of times, you can run the routines a couple of times, and then pick the best one for you. So that functionality we're also testing right now. And so, you know, I mean, kind of the overall general premise of this is that if you have additional functionality like that you want us to go and program, we're available to go and do that and then expose it through the API for you. So Ben, you want to describe your script real quick? I think we have 4 minutes before our time.
Yeah. So we have shown here a couple different steps that are happening. So I'm just going to do a quick freeze. And we are going to go back to one. So basically, I'm using Dynamo's built-in point-by-coordinates creation node and having some inputs to both of these point-by-coordinates. And so it's really, you know, it's pretty straightforward. I'm picking a z height for these points that go into both of them. I'm making, this is a 2D plane, right? So I froze after this node. So we're just going to take a look at what it does. So it generates points at 15 feet at a certain spacing, right? So those first two blocks or groups just generate these blue points. After those blue points, we feed those points into this Python script that is pretty important to do drawing this conduit using the Revit API conduit create directly using, you know, the actual API from Revit. It's the only way I know how to actually draw conduit from Dynamo is to do it in a Python script like this. So it inputs points and inputs the level and inputs a conduit type here so that we know what we're trying to route. And so if I unfreeze that one, oh wait, unfreeze this, it should draw 2-foot length pieces of conduit between the points that I put in those first two groups. And then the last step is feeding these 49 start and target stubs, just like Jack showed you. I just generated them in Dynamo, and now we feed them as a list into feed them. I break them back up into two lists of a start and target because in the draw conduit step, they were all drawn in one swoop. So I split the list into two, and the first half of them are the start points, and the second half of them are the target elements. Target element. We do have an important step that passes the element IDs to our routing block here. So we need the element ID as a list of element IDs as the start and target points. And so I could go into Revit and I can manually I could point-to-point route like Jack showed you, closest, and route between them, or I can do the same thing in Dynamo and put the start and target element IDs in, and the engine spits out the result. Yeah, so it's basically how it is, and we have a couple Python scripts in there, so it's important to generate these stubs to draw conduit through Dynamo. Take a look at those, and we can talk. If you have any questions, feel free to email me. I'm ben@buildingsp.com, and yeah, let's see if there's anything else.
Okay, and with that, I think we're perfect on timing. So thank you, everyone. Have a great Friday and a great weekend. And if you have any questions, feel free to reach out. We're here, and if you have betas, go give it a whirl. All the beta folders that we sent out last week have the Dynamo script in there, so you don't have to write all that yourself. You can look at how Ben did it, and then go from there. We also have sample batch files in there as well. So thank you everyone for your time, and if you enjoyed this presentation, we have many other webinars that we have planned. The next one that we have planned is perhaps a discussion of what generative design is and an example of how we can do generative design within Dynamo, GenMEP, and Revit. Or if you have other suggestions for webinars, we can address those as well. So again, thank you very much, and we look forward to hearing from you.